So this video is going to look at the homework that was originally assigned on Tuesday on page 54 in the book. We've extended the due date through today, Wednesday, so there's actually 2 days that you get to work on this homework. I'm going to do a series of videos, so not try to fit everything into one because there are a lot of problems on this assignment. On this first video, I'm going to do a sample from the first page. So I'm going to work on number 7. And I am also going to look at one of the completing the square problems, number 25. Just a quick reminder, number 12 that is on the agenda as an assigned problem is not. So don't have to do number 12. You can cross that off. We'll come back to problems that involve this funny thing here, this I, another time. All right, let's jump right in. Number 7. Now, the instructions for this set say to solve the equation by finding square roots. And what that is saying is that you want to get the equation to look like something squared on the left equaling some sort of number on the right. And then you're going to find out what x is by taking square roots on both sides. So in most cases in these problems, you're going to do all of that by factoring. So let's take a look at number 7 and see what that looks like. X squared minus 22x plus 121 equals 13. And once again, I want to get this equation on the left-hand side to look like something squared. And in order to do that, I need to factor. So that means I'm going to look for numbers that will multiply to give me 121 and add to give me a negative 22. And I think that would be a negative 11. Negative 11 and negative 11. So I could factor the left-hand side into x minus 11 times x minus 11. And of course, it still equals 13. I can rewrite that x minus 11 as x minus 11 squared, right? I've got something times itself, x minus 11 times x minus 11. So I'm going to condense that and write x minus 11 squared equals 13. Now it looks like something squared on one side equals a number on the other, and the next step is to take the square roots. So I'm going to take the square root of x minus 11 squared, and I'm going to take the square root of 13. The square root of anything squared is just what that thing is. The square and the square root cancel each other out. So I'm left with x minus 11 on the left. And on the right, I've got the square root of 13. Now, I need to be very careful here. When I take a square root and I have an equation, I really am looking for the positive and the negative root. So I have to include plus and minus square root of 13 in my equation. All right, one less step. I'm going to add 11 to both sides. So now I've got x equals 11 plus or minus the square root of 13. Now I can leave this just as it is, those two answers, x equals 11 plus the square root of 13, or x equals 11 minus the square root of 13, or I can kind of approximate things if I punch the square root of 13 into a calculator. So let's see, 13. Square root of 13 is about 3.6. So 11 plus 3.6 is about 14.6. And 11 minus 3.6, so that square root of 13 is about 3.6, should be, let's see, 7.4. So either I can make an approximate answer or leave it exact. It's not really telling me which to do. I think I'm going to leave it exact for right now. So there's number 7. Let's take a look at number 25. Number 25 asks us to complete the square. So this time we're asked to solve the equation by completing the square. So a little bit different. I am going to use some factoring, but I have to create a situation where I can factor. So all of the problems up here, 3 through 11, are quite nicely factorable. But when you get down to these problems, 22 through 33, all of a sudden I can't factor anymore. So I have to do something else to the equation in order to be able to factor. So let's try that with number 25. So number 25 is x plus 12x plus 18. So x plus 12x plus 18 equals 0. This is number 25. All right, I totally can't factor this problem. There are no numbers that will multiply to give me 18 and add to give me 12. So I need to complete the square. And in order to complete the square, I am going to follow a couple of steps. Step number 1 is to move the constant term, that 18, to the other side of the equation. So I'm going to move a constant to the other side of the equal sign. When I do that, I'll have an equation that looks like this. X plus 12x equals negative 18, right? I'm going to move it by subtracting 18 on both sides, so minus 18 and minus 18. Notice that I'm leaving a little bit of space after the 12x before I hit the equal sign, and I'm doing that because I'm going to create a term here so that I can complete the square, right? Usually when I factor, I have x. Ooh, I forgot my x squared here. Ooh, there we go. That's a little better. X squared plus 12x plus some number, right? I don't have that some number. The 18 didn't work, so I moved it over to the right side, and I have to get some number to put here in this box that is going to allow me to factor. And we have a magic trick to do that. It is to take the b term, the middle term, and divide it by 2 and square whatever we get from that dividing. So this is my next step. To figure out what b is, in this case it's 12. I'm going to divide 12 by 2, and I'm going to square whatever I get. So 12 divided by 2 is 6. And 6 squared is 36. And that number, that 36, it's what gets filled into this box. So now I have something that looks like this. X squared plus 12x plus 36 equals negative 18. But hang on a second. I can't just sort of randomly add whatever I want to one side of the equation. I have to do whatever I do to one side to the other. So if I'm going to add something to the left side, I better make sure I add exactly the same amount to the right side. So I need to add 36 to the right side of the equation. So step 3 is to add that b squared minus 2, or b minus 2 squared to both sides of the equation. All right, let's clean this up a little bit. Over here on the right, I've got negative 18 plus 36 is positive 18. And on the left, I have something I can factor because 6 times 6 gives me 36, and 6 plus 6 gives me 12. So x plus 6 squared. And if you're not quite sure where that's coming from, think about this. All right. I want numbers that multiply to give me 36 and add to give me 12. And 6 times 6 gives me 36. 6 plus 6 gives me 12. So I could write this as x plus 6 times x plus 6. But remember, way back at the beginning of this other problem, that what I really want is something squared equaling some number so that I can take the square roots, right, to find out what x is. So really what I want here is not just x plus 6 times x plus 6, but x plus 6 squared. And that really means the same thing, right? Just something times itself, and I'm multiplying x plus 6 times itself. So now I have on the left x plus x squared. On the right I've got 18. I'm going to take the square root on both sides. So let's see, what did I do? I factored, right? That's how I got the x plus 6 squared. And now I'm going to take the square roots on both sides. Take the square root of x plus 6 squared. Take the square root of 18. And now I've got x plus 6 on the right. I've got the square root of 18 on the left. And here is where I always remember, oh yes, when I'm taking the square root in an equation, I have to remember to do plus and minus. We are almost done. I'm going to subtract 6 on both sides. So now I've got negative 6 plus or minus the square root of 18. And then I'm going to simplify the square root of 18. The square root of 18 is 9 times 2. And 9 is 3 times 3. So this becomes a pair of 3s. I'm going to pull that to the outside. So I've got negative 6 plus or minus 3. And then that 2 is left over on the inside times the square root of 2. So 2 possible answers for this problem. X equals negative 6 plus 3 times the square root of 2. And x equals negative 6 minus 3 times the square root of 2. Not 3, 2. There are my answers. If you want some more help in figuring out how to break things down, so like break those radicals down, what I did over here to get from the square root of 18 to 3 times the square root of 2, make sure you ask in class. I'll make some videos about breaking down radicals. All right. I am going to stop this video, but if you'd like to see how to do some of the other homework problems, check out the next videos.